Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Gabor. Hi Gabor, tell us a few words about yourself and about the tool you want to show us.
Hello, Alexei. So I am Gabor Szarnyas. I am based in Amsterdam and I work as a DevRel for DuckDB Labs. DuckDB Labs is this company behind the open source software project DuckDB that we will talk about today.
Yeah, so you probably have a demo for us.
Yes, let's jump right into it. So let me share my screen. And here we have a Jupyter environment prepared for you. And this is a social network dataset. So we have this person directory with a bunch of CSV files. Let's peek in. So the files themselves look like any regular CSV, except it's not really comma separated. We have these pipes as the separators. But other than that, we have timestamps, we have IDs, strings for the person names, some dates, etc. So it isn't too complicated. And I prepared a notebook to show you how we will load them in various systems. So the first idea is to use Pandas data frames. In Pandas, you would say import Pandas. You would create a glob to iterate through all of these part CSV files, and then you would concatenate them together into a single data frame. So if you can read the rest, we specify the delimiter and then get the number of rows that we have read. And if we run this, it is roughly 500,000 lines, and it took like 1.3 seconds to run. Another popular tool to deal with data frames is, of course, Spark. Here again, we have to do some explaining that we import Spark, we create a bunch of options that specify the delimiter, say that there is a header, and then we load the part CSV files as previously, and then we print the count. Of course, Spark takes some time to get started, and then it loads the data, and it roughly took 5 seconds to load.
I'm surprised. I expected it would be higher time, longer.
Yeah,
it's like it needs to warm, like there is all this overhead.
But it's running locally, so it gives it some advantage. Let's move on to DuckDB. So with DuckDB, we are going to use this magic DuckDB package that allows you to interact with DuckDB via Jupyter. And next, I am going to run the loader. And for this, I didn't even type the full query before because it's so simple. We just say create table person as, and then we say we would like to select everything from the person directory and the part CSV files. And we didn't have to specify the delimiter. We didn't have to specify that the file has headers. DuckDB figured out all of this on its own and loaded it in less than half a second. So it's very snappy and very easy to work.
How does it know the delimiter?
So it has something called a CSV sniffer. It takes a CSV file and it samples it, and it tries to figure out what the delimiter is, and it also figures out detailed data types. So we have something called describe in DuckDB, and if you run this, you can see that it actually correctly deduced things like the creation date, which was a full timestamp of a second to millisecond, and the birthday, which was just a date, and also the rest of the attributes, which were either strings or integers. So this makes it, of course, very pleasant to work with. And
Spark also has similar functionality, right?
Yes, the infer schema
takes longer.
So this is, of course, something that users prefer, and we usually tell users that even if you don't trust the CSV sniffer 100%, it is very beneficial to run it, get the schema from DuckDB, and then you can manually review it and maybe alter it if you need slightly different data types. It will make your life a lot easier if you have dozens of different tables in various CSV files. So, of course, the data is now in DuckDB. We can say trivial queries like select star from person. You can see that we have a bunch of attributes here that show up in this notebook. And of course, we can run SQL queries on it. So DuckDB supports something of a PostgreSQL dialect. It supports the full syntax with a couple of extensions. So one thing that we may say is that we would like to just filter this based on the birthday. So birthday is smaller than 1985, 1st of January. And then we can see that this actually worked, and it gave us an instant answer of people who were born before that date. We may want to look into something like what is the most popular first name in this given date. Now for that, we would say that we would like to count the instances for every first name. And of course, we would like to do an ordering on that. So order by the count and do a descending order. But if I run this query, I get a syntax error because of something that we all tend to forget, which is the group by. So the parser will say that the group by is missing from the query. So of course, one just goes back and says, I would like to group by first name. We run the query and then we get John as the most popular first name. The problem is that if we add another attribute, then this group by will bite us again, and we have to manually maintain this. This is very annoying for interactive data analytics. And this is also that the computer just figure out on its own. So we could just say, well, it knows that we want to get the count of the first name and the last name, so it should be an automatic process. And DuckDB supports this. We have something called group by all. And in this case, we can just go back and forth with the attributes, and it figures out what we would like to do. So this is very handy to work with. And this is a feature that our users like quite a lot.
So Postgres does not support this, right? Only
Postgres does not support this, but other vendors
That's very handy. That is very handy.
It is very handy. And some other vendors have already adopted this. So this is a popular feature. Another popular feature is that we offer gradual integration with Pandas data frames. So we understand that users do not have time to take their Pandas applications and fully rewrite them to DuckDB. So we allow you to jump back and forth between the DuckDB world and the Pandas world. Here's a small example. So we say, import DuckDB and take this person table that we have just played with and turn it into a Pandas data frame. And then we can use the good old Pandas syntax to filter for things like people whose name is Anderson. And then we get a Pandas data frame back as a result. And the proof that this back and forth integration works really neatly is that we can then continue with DuckDB, and then we can say from Anderson, which it will figure out based from the variable name, and apply the same filter again. And then we get a DuckDB CLI query working on the data frame. So it is all very snappy.
What kind of magic is that?
It is called a replacement scan. And the replacement scan allows you to notice that this Anderson is the same Anderson. It is surprising. It has this factor. Finally, of course, sometimes you want to dump your data back into some easy to read binary format, preferably one where you don't need the CSV sniffer to actually work over time to detect the delimiter. So here we have an export database function with format Parquet. It says it's successfully exported. So let's jump into the terminal and see what happened. What happened was that it created something called person-db. And person-db is a collection of files. It has a load script, a schema script, and a Parquet file that we can load. So DuckDB allows you to export the database and import the database back using this script. And DuckDB comes in different distributions. So what you have seen previously is based in Python. So it runs in Jupyter and in Python environments. And this one runs in regular command line. So I just run the DuckDB client. And one thing that this Parquet format allows us is to create the database again. So we can say create the person table where the table will be created from this person Parquet file. It loaded it almost instantly, didn't even take 100 milliseconds. And now we can again observe that we have all the attributes that we have seen previously, and we have an interactive SQL shell. So for some people, this is the preferred way to interact with DuckDB. You can again run queries like select everything from person, and you can wrangle the nested data sets. For example, we have this email attribute at the last column, which seems like it has a semicolon separated attribute embedded. So we can say that we would like to split this on the semicolon and return it as an attribute of a list. And once we have this attribute, we can also do unnesting, and that will turn the email addresses into individual rows. So now we have unnesting. We can see that there is also some dirty data because apparently some people have multiple instances of the same email address, and we can just deal with that using select distinct of SQL. And now we have a list of unique email addresses. Apparently there are roughly 1 million unique email addresses in the data set. So this is all very neat, and a lot of the JSON style data can be handled with support for nested data, unnesting, and similar operations. So this is another syntax feature. One thing that people really like is that you can just say from person, because we reckon that the part select star is a bit redundant. So from person will give you a sample of a table, and another feature that we use to extend the select part of SQL is that you can say that you would like to get the columns, but you would like to exclude a few columns. So maybe in this case, you are not interested in the
This is so useful. Like why it's not everywhere?
It is something that we find very popular. So as you can see, it's very easy.
Of course, like it's like it has been a dream of mine for like, I don't know, since I started working to be able to simply exclude. What I previously would do is like, I don't know, describe, see what all the columns are, and then drop the ones I don't need, and then copy, paste this thing. Yeah.
Yes, it is
So cool.
also a source of frustration for me ever since I've been an undergraduate student. The group by all is my personal favorite, but exclude is great, and the from is also a great feature. So this is a couple of DuckDB's syntax features, and we pride ourselves in the fact that DuckDB is extremely portable. So you have now seen the version in Jupyter, the version in command line, but you can also run it in a browser. So if you navigate here, this is shell.duckdb.org. This runs exclusively in your browser. And this is a very handy way to run SQL in your browser. I don't have any data here, so I will just run a query that sums up the numbers between 1 and 100 million. So we have 0 to 100, 1, 2, 3, 1, 2, 3. And this is just a small table. And then this runs the query in less than 200 milliseconds. Of course, this is not the actual use case of it. The actual use case of being able to run SQL queries in the browser is that you can run dashboards, and they are very snappy and interactive, because the last bit of the analytics, when you just do a final filtering step or a sorting step, that can all happen in the browser, run in WebAssembly. So this
How do I put data here?
So you can fetch data from online sources. This is, you can interact with the server, you can read from S3 buckets, and that will be your primary way to get data in.
So for example, let's say I want to, it's a hobby project, not for work. I can just put a CSV file to my GitHub and then they use the raw link saying, hey, fetch the data from here.
Yes.
I see.
So that should work. And once the data is loaded, of course, this is also a full-fledged version of DuckDB. So you will be able to say things like create table here, and that will make it, again, a lot easier to run queries, create table like so. And then you have your table and everything works just as it would with normal regular DuckDB. So this was DuckDB in a nutshell. It is an open source project, so you can go on GitHub. It is mostly written in C++. So the code base is C++, and it is roughly 200,000 lines of code. So that allows you to take it as a single file and compile it anywhere. And of course, this is what empowers us to have a very portable version of DuckDB. If you visit duckdb.org/docs/installation, you have all the different clients that we cater for. So other than Python that I already shown, we have R, Java, Node.js, we have an ODBC connector, and we also have client APIs for Julia, Rust, Scala, Swift, and so on. So this is a truly portable system, and different versions of DuckDB can persist data in the same format.
That's awesome. And I have a few questions. So when you create a database, like when you wrote create person, so this is like session based. So next time I restart, let's say my Jupyter session or my Python or my like DuckDB shell or whatever. So this will be gone, right? And I need to execute this statement again, right?
So thankfully, this is not the case. You can start a DuckDB instance with a file. So you can say my.db. And then this is a single file that contains all your data. And if you create the person table from this Parquet file, and then you exit, upon reconnecting, you will still have your person table and you can still
that's useful.
get data from it. And this format is something which, of course, doesn't require a lengthy loading process. You just add the DB file to the invocation of DuckDB, and then it can read data instantly from it.
How do you install it? Is it like apt-get install DuckDB or pip install?
So it is pip install DuckDB for Python. We have brew install for macOS. We also have winget for Windows. And for Linux, there is no official package yet, but
you just have a binary, right?
Yes.
Okay, and it, I assume, works on pretty much any Linux, right?
It is. So the
as long
idea
as
of
architecture
DuckDB,
matches.
Yes, we try to make it as portable as possible. So it works on ARM architectures, including the Amazon Graviton CPUs, the Apple Silicon CPUs, and the CPUs in smartphones. So this is all.
Okay, so I can install it on my Android.
Well, I can show even one better. It is actually running in the shell. So you can take shell.duckdb.org. And if I can just type select 42, which is the typical geek query, then you can see probably my phone that it runs select 42. So it runs in the browser on the CPU of the smartphone.
It's amazing. How come it's so fast? Like parsing CSV is not the fastest thing you can do, right? But
yes,
DuckDB
so
was able to. How does it like? How is it so fast?
So one of the things that we would like to explain to our users is that your laptop is a lot faster than you would think. So if you have a laptop from the last 5 years, it likely has a fast disk. It has quite a lot of memory, 8, 16 gigabytes or more, and 4, 8, or even more CPU cores. And DuckDB leverages the multiple CPU cores, so it's parallel. It's leveraging that the disk is fast. So if it would start running out of memory, it would spill on the disk. And it uses a columnar representation. So the columnar representation allows it to have very good compression. That, of course, saves bandwidth both in memory and on disk. And if you put all of these together with the optimizations that the CSV reader has, we have a CSV reader that reads at more than 1 gigabytes per second. So it is quite snappy and can get the data in very quickly.
So what you're saying is DuckDB is just pretty good at utilizing like normal standard hardware, like
Yes.
usual laptops, while maybe Pandas is not the most effective way because like it's Python, it's slow.
Yes.
Like it has indices and all that stuff.
And they have been conceived in an age where a single-threaded architecture was the norm. And for DuckDB, it was obvious from the get-go that it needs to be parallel. And DuckDB also uses tricks that allow the compiler to optimize the code. So we rely on a feature called auto-vectorization. When the compiler finds tight loops in the code and it optimizes them to be executed with SIMD, single instruction, multiple data instructions of the CPUs. And this is, of course, tricky because it has to be portable to different architectures. But here we rely on the compiler optimizations. So the popular architectures tend to have very good compilers these days, and they can arrange a fast execution path for DuckDB's code.
Yeah, that's awesome. When you showed the GitHub page, I saw that there are 255 contributors. That's
Yes.
quite a large number. How many of them are, let's say, core contributors that work? I know that there is the company you work for, which is DuckDB Labs. There is another one, MotherDuck, right? So
Correct.
I assume some of the developers who work in these two companies, they're like core contributors who always support DuckDB. So how many of those people are there?
So here we at DuckDB Labs, we are based in Amsterdam, and this is roughly 15 core developers of DuckDB. There are contributions from our partners like MotherDuck, and we also have roughly a few dozen open source contributors who regularly contribute to the code base. So it is a medium-sized software community. And one thing that we noticed with DuckDB is that the project is not huge. So 200,000 lines of code is not a particularly large project, but because of all the integrations that DuckDB has with Python, our various data frame libraries and other languages, we have a rather large surface area. So it's incredibly valuable that we have a user base as an open source project, and the users can both point out bugs and submit occasional patches. So this helps us a lot in ensuring a nice user experience for DuckDB.
My next question is about contributing, how people can contribute. But I see right now you're sharing your screen, and I see this contributing.md file, which
Correct.
probably has the answer to my question.
Yes. So one thing that we always tell people is that the project is currently moving at a pretty rapid pace. So it's prior to version 1.0, and things can change quite rapidly. So before embarking on a major feature implementation, please talk to us, because there may be some information that we can share that will influence on how you implement that. Another thing is that we would like to keep the core database with the SQL engine and the CSV reader and the minimal viable core of DuckDB. We would like to keep that rather small. So we have an extension mechanism, and many of the things in DuckDB are implemented as extensions. Even something like the Parquet reader that you have just seen is implemented as an extension. So we have extension for the Parquet format, as I just said, extensions for reading Postgres and SQLite files, extensions for integrating with AWS, Azure, and so on. So these are all maintained as separate projects from DuckDB. And if someone would like to interact with DuckDB, but maybe it is not their goal to get their contributions merged into mainline DuckDB, then creating an extension is an excellent idea.
Okay. Last question.
Okay.
Do you have any advice for anyone who is watching this?
Well, I think DuckDB is easy enough to take for a spin. So select your favorite platform and give it a go. So it's likely that we already have an integration for that. And it's also likely that you can get started with DuckDB gradually and just maybe replace that particular difficult bit of your Pandas code that always takes minutes to complete and see how it works out.
Yeah, thanks. Yeah, awesome demo. Thanks for joining us today, for showing the demo, for answering all my questions. And yeah, it's pretty amazing how fast it is. So I hope everyone will try DuckDB after this demo, and do not forget to give them a star.
Well, we would much appreciate that. Thanks so much for having me.
Yeah, thanks.